one. Thanks for coming tonight. Just a quick thought. One of the things that's changed for me in COVID is I'm listening to a ton more podcasts. I don't know why, I guess cleaning up in the kitchen, going for walks. But one that I found that I really love was the most popular course at Yale for 4 years running, which is called the Happiness Lab. And it's about the science of happiness. One of the things, she always has different things. I really enjoy them, especially the science part of it, the actual scientific studies. But one is around, our minds tend to gravitate towards negativity. I think in COVID, this is a difficult thing. And of course, with our buildings challenge that we're trying to solve here, it can be negative. But one of the things, and you see this in lots of science studies, is recognizing gratitude can really change people's happiness levels. So, just spending 3 minutes to write down 3 things each night that you're grateful for can make a huge difference. So let me just tell you what I would write tonight, which is I had 2 meetings with our acting CEO today. I was very worried they would go bad, off the rails. And actually they both ended at early and I got exactly what I wanted. So those 2. And one is that Passive House Network submitted a request, one of the presentations I've done for them on Passive House multifamily performance and incremental cost in Massachusetts, about scaling of Passive House here in Massachusetts. They submitted to ACEEE for a paper that I would write, and we got accepted for their summer institute. So woohoo, those are 2 things. More work for me, yay. But anyway, tonight for a toast, I just say, let's all think about what we're grateful for. I've heard Ed May needs basically no introduction to this crowd, since he was one of the very first speakers, which I missed, I'll have to admit, at the beginning. Ed's an architect and Passive House consultant, both standards. He does designer and consultant. He has that certification. He is with, oh dear, my notes are terrible, Building Type, which I think many of you guys know him because he works with Michael on a whole lot of projects in New York and Brooklyn, and then additional ones. And I've got to say, for this topic, I can't imagine a better person with more experience than telling us about what kinds of challenges around air tightness that he's encountered. So, and I was happy, just very quickly, I didn't, reading his bio, he has a Massachusetts tie-in. Since I work for a Massachusetts agency, I went for undergrad to University of Massachusetts at Amherst. Ed, we're really looking forward to your talk tonight. Talk about practical, perfect for the theme for this month. We can't wait to hear your presentation.
Fantastic. Well, thank you, Bev, and thank you everyone else. So I am going to try and share my screen, and hopefully everybody is able to hear me okay. If somebody could maybe give me a nod or something, let me know that you're able to see my screen okay and able to hear me okay. That would be terrific. All right.
That's great.
Fantastic. So thanks so much for that kind introduction, and thanks to Zach and Michael and everybody, Sean, everybody at House Accelerator. You guys are doing such amazing work here, and thanks for the invitation to speak with you guys tonight. Super fun to be back, and nice to see everybody. Nice to see a lot of familiar faces here. Awesome to get a chance to talk with you guys. So I should just briefly. That's a great introduction. I'm actually no longer an architect. Got rid of my architecture license. I used to be a builder, no longer a builder. Used to be an architect, no longer an architect. I am mostly nowadays a Passive House consultant, and I do a little bit of educating on the side, a little bit of teaching and instruction. As Bev said, I'm certified with both Passive House Institute and Passive House Institute US, so we work in both standards. And I have the privilege of teaching for all sorts of great groups like Passive House Canada, North American Passive House Network, or Passive House Network, New York Passive House, previously Passive House Academy when they were operational here in the States. And I've also worked for several different universities in the past, both Stevens Institute of Technology and Parsons, the New School here in Manhattan. So I'm based in New York, in the New York metro area. And as I said, super happy to be with you here tonight. So just super briefly, a little bit more about me so you know who the heck I am. As I've said, I'm a partner in the building performance consulting firm Building Type. We have a silly written name, but we pronounce it Building Type. As I said, we do mostly or almost exclusively Passive House certification to the FIAS and PHI standards. We come from an architecture background, so we focus mostly on the envelope side of the coin, on energy modeling, on construction phase consulting, detailing, working closely with the teams on communication. Time was that I spent a lot more of my day out in the field. I spent a lot more of my week with a hard hat on. Nowadays, most of my time is, like a lot of us on the call, I would imagine, sitting behind a computer. And in fact, probably 50% of my time nowadays is spent developing software tools as part of the Passive House Tools project, where I'm a developer and the maintainer in that project, building software tools, modeling tools to help Passive House designers do better, faster, quicker, cheaper. And so that's a whole other project we can talk about someday, but that's just a super quick introduction to the kind of things that we do. So when the folks from Passive House Accelerator asked me to be here tonight, they said that the theme for this month was air tightness, and so I said, "Oh, you know what we should do? We'll do a bit of a sort of overview of air tightness. We'll talk air tightness. It's a great topic, a super interesting topic." And what I thought would be interesting is if we share my top 10 list of ways to screw up your air tightness result. I don't mind sharing things we've screwed up. We've been doing this for a long time. We've screwed up a lot of things. And so I'm more than happy to share those. And maybe we can head off a few future failures. And of course, as we go through, I'd love to hear your thoughts. And if you want to share some of your failures as well, that would be awesome. Feel free to add those to the chat. So if you're new to Passive House, you might be thinking, air tightness in a building? That sounds like a weird idea. And yeah, it's a weird term. Whoever was in charge of branding that day maybe needs to go back to the drawing board. Air tightness is a weird word to use when we refer to buildings. It's kind of an unfortunate term, but we're stuck with it. Air tightness is an important piece of the puzzle when it comes to delivering Passive House buildings, and it's important for those of us on the design consulting side to educate our owners, builders, developers, architect colleagues on why airtightness is so valuable, so useful, so helpful, so important to our Passive House buildings. Now, why is it so important? Why are we going to spend a whole session here tonight talking about airtightness? Why is it such an important thing? Well, it is, of course, true that when we build airtight buildings, we use less energy. That's a good thing. It is also true that when we build airtight buildings, we improve the thermal comfort of the buildings, less draftiness, less humidity in the summertime. Those are a good thing. It's also true that when we build airtight, we're going to improve indoor air quality. That's definitely a good thing, improving the health of our occupants, less pollutants, less particulate matter, less allergens from the outdoors coming into our healthy buildings. Those are all good things. Those are not really the reason why we care so much about air tightness. Those are all important things. Those are all valuable things. We love those things. But the reason that we dwell on air tightness, that air tightness is so important, that it's such a fundamental tenet of Passive House buildings, is because it goes directly to the question of durability. We want to make sure that in our high performance, healthy Passive House buildings that we're designing and spending all this time and care designing and creating, we're never going to have a situation where we have warm, moist air coming in contact with a potential condensing surface, that warm, moist air riding on air currents as it moves through the envelope of our building. This is exactly what we're trying to avoid. And why do we care about it so much in Passive Houses? Well, in many cases, we've added a whole bunch of insulation, a whole bunch of fluffy stuff to the walls, roofs, floors of our buildings, and that fluffy stuff has done a real good job of retarding heat flow and slowing down the thermal energy as it moves through the assemblies of our building, and that can leave behind, in some cases, some cold surfaces. And those cold surfaces are at sometimes higher risk of mold, moisture damage in those buildings. So the reason we focus on airtightness is primarily around durability, though it does have all sorts of additional benefits as well. But it's absolutely crucial to building a healthy building for the long term. Now, of course, if you're certifying buildings, if you're designing buildings to certify to either the PHI US or PHI standard, as I've noted, we work in both. Both of those certifications are going to have incredibly stringent airtightness requirements. So in addition to all the good things we get when we build an airtight building, we also have to build an airtight building if we want to try and certify our building to either the FIAS or PHI standards. Now, the specific limits are going to change and vary depending on the type of building, the size of the building, the type of certification that you're shooting for. There's all sorts of weird numbers that we can dive into at some point if you're interested about the exact limits for where those certifications lie. But more or less, they're all going to force us to build an extremely airtight, extremely durable over the long term building if we want to certify to one or the other of these protocols. Now, whatever protocol you're going to certify to, whatever certification standard you want to certify to within the different protocols, you're going to see in a passive house building very, very low levels of heat loss, very, very low levels of air infiltration and exfiltration. As I said, one of the benefits that we get from air tightness is that it significantly reduces our overall energy consumption, reduces heat loss in our buildings. This is just a graphic that I grabbed from a recent project of ours in our office. It's a townhouse retrofit that we're doing to the EnerFit certification. And I just grabbed this graphic out of the report, the assessment report that we produced a few weeks ago, just as an example. It's just an example of the kind of thing we see when we plot air tightness on the horizontal axis against heat loss on the vertical axis. You can see here the rising heat loss as we move to the right on the horizontal axis as the building becomes leakier, as the air tightness becomes worse. So no matter what passive house standard you're certifying to, no matter what certification level within the standard you're certifying to, you're going to be way over on the bottom left-hand corner of this graph. So we have to build very airtight buildings. We have to achieve very high level of air tightness. Okay, so we care about airtightness. It's super important. We've got to focus on it because it's the right thing to do, but also because we want to certify our buildings. However, there are 1,000,001 ways that we can fail to actually achieve our airtightness goals. Now, I'm going to focus on 10 failure types that I've observed in the field, that I've seen in my own work and in our own colleagues' work over the last dozen or so years that we've been designing and building these passive house buildings. But of course, there are many more. And as I said, I hope you'll volunteer yours to the chat here this evening as well. So there's lots of different ways that we can screw it up. There's lots of different ways that we can fail. I have 10 in no particular order, but I would like to sort of offer maybe 3 different categories, maybe the 3 different ways that we can kind of categorize our failures. So I think we can sort of say that in general, we have a category of failures that we can call planning failures. These are failures that happen for those of us with pencils in our hands, computers at our fingertips in the planning phase. There's another class of failures, a different type of failures that happen in the implementation phase. All the best planning in the world, if it's not implemented correctly, results in a special class of failures. And then there's another set of failures that happens on the tail end around the testing of our buildings. So there's another type of failure, another class of failures that we see when it comes to airtightness around the testing side. More or less, that's not testing enough. But we'll get to those, of course. So let's kick it off. Here are my top 10 list of ways to screw up your airtightness of your building in no particular order. Let's start with the planning failures. The number one way to screw up your airtightness, not knowing where your air barrier is, not having properly thought about what the air barrier of your building is. On any passive house building, there should be one continuous airtight layer, and you should be able to execute what we call the red line test. Now, the red line test is best done on a piece of paper. It's not best done in the computer. I know we're all on the computer all day. Do this on a piece of paper. Print out a plan, print out a section of your building, go down to the local CVS or Rite Aid, get yourself a big fat red marker. Take that big fat red marker, start in one corner of the building, and trace the airtight layer of the building. And if you ever come to a scenario, a spot where you're confused or you're uncertain about how the airtightness is going to transition, how it's going to connect different layers, you put a big red circle. And then you come back and you detail it properly. As I said, there should be one continuous airtight layer with no breaks or gaps. And it should be very obvious. You should know exactly where the airtight layer is in all of your assemblies. Of course, our assemblies are very complicated. We have lots of different materials and layers in them, but you should know which one is the airtight layer. There should be no ambiguity or confusion about that. Now, you can have more than one. You should have one, but you could have more than one airtight layer, especially if you're doing something like compartmentalization in multifamily buildings, right? So many larger buildings, we want to compartmentalize, make sure that if one person is in an apartment is cooking fish or smoking, that doesn't get into another person's apartment. So you might have interior airtight layers as well. That's great. That's all well and good, but there should be at least one continuous airtight layer around the entire conditioned space of the building. Now, number 2 on my list of ways to screw up your airtightness is not knowing how the pieces of your building are all going to connect together, more or less not detailing your building well enough. I have observed, and I think I'm probably safe to say, that in North America, in the United States at least, where I operate, coming from a very United States perspective here, admittedly, in the United States at the residential level, many architects, developers, builders have more or less over the last 20, 30 years outsourced the detailing of their residential buildings to the product suppliers, to the manufacturers. You go to the window supplier and you ask them, what is the install detail for your window supposed to look like? For passive house buildings, that doesn't really fly. For passive house buildings, we have to have enough documentation and enough resolution in the planning phase to know exactly how all the pieces are going to fit together. And if you don't know, if when you're looking over one of your details, you're confused, if you're scratching your head about where the airtight layer is, how it's going to connect, and you're confused sitting in your air-conditioned office in your cushy seat, I can guarantee you that the guy up on a ladder in the rain, in the snow, will also be confused. So resolve this during the planning stage. You should know exactly where the airtight layer is. You should know exactly how it's going to transition, what products are being used, and how that airtight layer is going to move around the entire conditioned envelope of your building. The other piece that I'll add to that is when you're doing this type of detailing, you need to be thinking about sequencing. We need to be thinking about first this and then that. First, I'll do this layer and then I'll have the additional layer. When it comes to airtightness, a lot of it is about sequencing and a lot of it is about how the different pieces come together over time. This is just one example of a detail. I saw Tim Spittler's on the call here this evening from R. Sutton. This is a project that we're doing with them in Manhattan. Those guys are doing an amazing job on a really nice backstaying multifamily building. This is a beam pocket detail. And as you can see here, they've done a great job of prepping the rough opening with an air tightness layer. That's the sort of white liquid applied material that you can see there, and before installing the sort of structural steel on the building, right? So really good thinking ahead, really good sequencing, good planning on a project like this. And my number 3 way to screw up your air tightness in the planning stage is to specify or plan to use materials that don't belong together, that don't play nicely with one another. Not all materials stick to all other materials. These photos are from actual projects of ours. The project on the left there, a commercial multifamily project. Clearly, that flashing material is not adhering to that roofing material. On the right-hand side there, that's an amazing project built by an amazing builder. But what do you see? You see, I don't know what, 15 different products there. We've got some zip tape and some ice and water and some zip and some, I don't know, 3 different tapes being used there. We've got a subgrade waterproofing on the foundation there. There's a tremendous amount of complexity going on there. Are you sure that all of these things stick to one another? Maybe they do, maybe they don't. You need to really think about these things when you're in the planning stage. Make sure that you're specifying the correct products. Now, I've heard Kevin Brennan say several times, and I 100% agree with this, just choose a product family and stay within that product family. I couldn't agree with that more. I don't care which product family you want to go with. Use whatever manufacturer tickles your fancy, but stick within them. Don't try and take a tape from this guy and a membrane from that guy and a roofing from that guy and sort of weave them together yourself, unless you're prepared to actually do the compatibility testing and the adhesion testing. Right? That's fine. You can do that if you're willing to actually do that extra work. So we've got a bunch of planning phase failures there. Absolutely. That's a good way to screw up our building, is to improperly plan. But there's plenty of other ways to screw up our building. As I said, we have a whole other class of failures on the build side, on the execution side. So my 4th way to screw up the airtightness on your project is to not communicate correctly to the installers what the heck it is they're supposed to be installing. You could maybe say this a little differently, having installers who don't have enough education in the specific tools, techniques, and needs of passive house buildings. So this is maybe a hybrid, this is maybe a bridge. This is both a planning failure and an implementation failure. So there's lack of education on one side and lack of communication on another side. Now, what you see in the photos here is the opposite. This is actually an attempt to overcome that. This is a few photos from a window installation mock-up. It's a project of ours from several years ago. You see a whole bunch of design personnel as well as a whole bunch of implementation personnel. We've got all sorts of folks from all sorts of different disciplines all together on the site, all focused on the question, how are we going to install these windows? How are we going to air seal these windows? How are we going to flash these windows? And we're working through it together on the actual job site with the actual guys who are gonna do the actual installation. You see the guys on the right-hand side there working through some of the taping, and we're working together to resolve issues or challenges that they perceive and come up with good solutions. Right? So this is an attempt to overcome these issues of not communicating well enough. There's a sort of a part B to this method, though, which is that even if you do a bunch of really careful work educating part of the team, especially when it comes to larger commercial projects, there is a strong likelihood that at some point, those well-educated team members are probably going to go off to another job somewhere, and you're going to get the B team show up on your job, and then you're going to show up on a job site. You're going to see things like this, and you're going to say to the installer, what the hell happened here? What's going on? And the installer is going to say to you, some 19-year-old kid is going to say, Eric told me to come over here and put some tape on the windows. Well, I spent 3 days with Eric talking about exactly how we were supposed to put the tape on and how you're supposed to apply it and some of the different conditions. You know, these things, these are the challenges that we run into when it comes to these types of commercial projects in particular, right? These are huge hurdles that we've seen on lots of different projects in lots of different places. This is not relegated only to air tightness. This kind of cuts across all commercial contractors for sure. So definitely a challenge. Definitely a good way to screw up your building is or screw up your airtightness is to really, really educate part of the company that's doing some of the installation. Now, another type of build failure that we've observed, my fifth way to screw up your airtightness, is to just carry on with business as usual. To just keep doing what you do, and then maybe layer on some of that passive house business as a sort of, you know, also we should maybe do that. We'll like fold that in somewhere after we do all what we're doing. What are you seeing in the photo here? What you're seeing in the photo here is one of our earliest passive house buildings. This is from, I don't even know, 2010, maybe 2009. And what happened here was that you see there's an air tightness membrane on the roof or on the ceiling. And the framing contractor didn't want to hear anything about it. He didn't want to change how they were doing their framing, didn't care about any of this business. And we were quite green and weren't prepared to force the issue. And they said, listen, we're just going to frame the building the way we frame the building. You guys can come in and put your air tightness membrane, and whenever we're done, when we're on to the next building, you go ahead and tape around all those interior partitions. Well, all right, I mean, we're going to use like twice as much tape, and it's going to be like, it's going to take us like twice as long. And it turns out we're going to do twice as bad of a job. This type of detail here where the air tightness is not continuous behind those partition walls, behind, in this case, the top plate of the wall. These are areas where we commonly see leaks, no matter how much tape, no matter how much attention you're going to put to that detail here. On the left-hand side, you can see an infrared image of air leakage during a blower door test. So the colors there representing different temperatures of air. You can see cold air leaking into the building under a depressurization blower door test, clear evidence of failure of this detail. And largely, this was because we didn't come up with a good detail that was something that the builder felt like they could actually execute. And they insisted on having us come in and do air tightness as a second layer. And that doesn't work. That's not going to work. Now, the sixth way to screw up the air tightness on your beautiful passive house building, this is an easy one, have doors in your passive house building. You know, the reality is 2022, in a modern passive house building, these types of buildings are really best appreciated from outside, looking at them from the outside, or from sitting inside with everything sealed up. This business about moving from the inside to the outside, you know, that's not going to cut it on these passive house buildings. Now, in all seriousness, though, doors are the place where we see the most significant failures Windows, for the most part, folks have a pretty good beat on at this point. Most windows are actually pretty decent when it comes to air tightness and reducing air leakage, but doors are a constant disaster. Every door we've ever installed, every door I've ever assessed, every door we've ever looked at has problems, has issues, has failures. And the biggest failures are almost always at the sill. Again, we see some infrared images here, the different colors corresponding to different temperatures. And you can see here, these are both images taken during depressurization tests. You have outdoor cold air coming into the building. You see the cold air leaking in under the sill of these doors. It's very common in a lot of buildings that we see. Now, that's a problem on small doors. It's an even bigger problem when the doors get silly. This is a fully certified PHI building with essentially walls of glass. I don't even know that you would really call these doors. I don't know what you would call these. Beautiful building, amazing design, lovely place, very challenging from an air tightness perspective. Those doors, giant walls of glass that move around, they're incredible. They're beautiful. They're amazing. They're incredibly low U value. They're really, really great from a thermal control perspective. They're very, very hard to install properly. Read the specification. It says that's a 4 meter long door. You want that to be level plus or minus a millimeter. Oh, well, do you? Oh, well, those types of installations are incredibly challenging, especially when we're talking about commercial construction. Right? That's a lot to ask for that door to be installed basically perfect. And then, of course, we see the biggest issue on these doors, even doors that have been installed more or less perfectly, more or less impeccably. We still see leakage at that middle rail, that check rail, the meeting rail there. The reality is those bypass gaskets are very hard to make airtight. It's very hard to get those to actually seat properly. So at that middle check rail on those lift and slide doors, there's almost always going to be some residual air leakage, even in doors that have been installed absolutely perfectly. These doors here, this is from one of the best contractors we've ever worked with. These guys did an amazing job. But even then, these doors are not perfect. You're going to see some air leakage at these doors. Got a plan for that. Assume you're going to see some air leakage there. What else do you see in this infrared image on the right-hand side there? Again, you're seeing temperature. Notice the temperature scale on the right-hand side goes all the way up to 92. How is that possible? Well, in many of our projects recently, what we've been doing, and maybe if you don't want to hear this, plug your ears, we've actually been installing a little bit of radiant heating right at those doors because we know that there's going to be some challenges around drafts and durability, condensation, and the like. So we've been installing maybe a foot, 300 millimeters of radiant, electric radiant right at those doors. That's a very common trick that we use in some of these projects. Only runs a few hours a year, but it gives the homeowner at least a button to press or a lever to pull if they are seeing some issues. And my number 7 method for screwing up your air tightness is to not use a service cavity. Right? Service cavities are a great way to keep electric and plumbing from penetrating your airtight layer. Is it possible to install the plumbing and electric in your air tightness layer and have it penetrate through? Yeah, you could tape the hell out of things. You could invest in a couple hundred rolls of dollars worth of tape per receptacle. You're still not going to get a very good result. You're going to see a bunch of leakage through those. The best thing you could do is just move all of that inboard of the air tightness layer, use a service cavity. I know it's a few extra inches, but it's absolutely going to make your life a lot better. And it's going to work great protecting that airtight layer. My number 8 technique for ruining your air tightness score, not paying enough attention to mechanicals. We often detail the heck out of the envelope connections, the window connections. We're going to work really hard and pay attention to things like doors. And then I will admit, I'm not a mechanical guy. I often lose sight of the mechanicals. Especially on big, complicated commercial buildings, you're going to have more mechanicals than you could ever possibly imagine running every which way around your building. And they're going to be moving through basically every surface on your building. You need to pay attention to those penetrations. You need to think about those penetrations, plan for those penetrations, make sure to educate those installers, and then go back into your quality control, make sure that you seal up those penetrations after the fact. So don't forget about mechanicals. They're really important. And especially on big buildings, commercial buildings, those mechanical penetrations are going to be some of the largest areas of air leakage on your project. Now, the last few, my last 2 methods for screwing up your building or screwing up your air tightness have to do with testing failures. So there's essentially 2 different ways that you can screw up the testing, and they both more or less are don't test enough. So First of all, my number 9 method for screwing up the air tightness on your building, don't do enough blower door testing. Blower door testing, it's not that fancy. Take a blower, a fan, you put it in the door. Thus the term, blower door testing. You put up some plastic around it. Then you run the fan to depressurize or pressurize the building, and then you can find and identify and fix the leakages through the envelope and the penetrations and the windows and the doors, all the areas of your building that are having issues. You should do many, many blower door tests. We've done as many as 12 blower door tests on a single project. You probably don't need to do 12, but you should do lots and lots of blower door tests. Don't be afraid of this machine. This machine is not magic. Everyone should have one of these machines. If you don't have one of these machines, just buy yourself a fan and 30 cents worth of plastic and plastic off a door and put the fan in the door and then run it. You'll still be able to feel those air leaks on the back of your hand. Maybe you don't have a fancy computer hooked up to it, but who cares? You can still identify and find those air leakage points. You should do this early and often. You should execute this blower door many, many times, this blower door test many, many times during construction. And my last way to screw up your air tightness, the air tightness on your building, is just to not use all of the amazing technology that we have available to us now. Talked a little bit about infrared imaging. Now, time was an infrared camera would set you back maybe $5,000, $10,000, right? Nowadays, that is not true. You can pick up a really nice, useful infrared camera, a durable infrared camera for a few $100s at this point. And if you, like me, style yourself a professional, you do this for a job, this is what you do for a living, I believe you should have the tools to do your job properly. So invest in yourself and your company and your tools. Make sure that you have the right tools for the job. It's not a big lift to get yourself a simple infrared camera. It's an amazing piece of technology. Again, allows us to more or less see the temperature of the things around us, right? So get your hands on the right technology and use that technology to do your job properly, do your job better when it comes to designing and implementing and constructing these passive house buildings. Now, of course, we don't have to use fancy technologies, though. There's a sort of a 10B. There are, in fact, some pretty simple tools that all of us have that we can use on our projects. One of my favorite tools that I deploy on projects is just my eyeballs. When I walk around and I see something like this, I don't need a blower door test. I don't need a smoke stick. I don't need a fog test. I don't need an infrared camera. All I need are my eyeballs in my brain to be able to say, hey guys, there's a 4-inch gap. And also that tape doesn't look like it's actually adhering to that masonry. It just takes a little bit of paying attention, a little bit of thinking, a little bit of eyeballs. The other thing I would say, the last thing I would say when it comes to this is don't be afraid to break stuff on the job site. The other tool that I like to use in order to assess air tightness are my fingers, my puny human fingers. If I, with my puny human fingers, can go through and ruin some of your air tightness detailing, if I can rip that tape off, if I can scratch that liquid applied membrane off, if I can damage your air tightness implementation with my pathetic human fingers, well, it was never really done very well in the first place, then, was it? I should not be able to delaminate or pull that tape off if it's been installed properly. Right? So go through, tug on things, pull on things, try and break things when you're on those job sites and see if they hold up. So that is Ed's top 10 list of ways to ruin your blower door test. And number one, not knowing where the air, which layer is the air barrier, not knowing how the pieces are supposed to connect together, using products that don't actually stick together, not telling the installers what the heck they're supposed to be installing. Part B, losing your well-educated installers to another job, carrying on with business as usual, having doors to your passive house building, not using a service cavity, not paying enough attention to mechanicals, not doing enough blower door tests, and not having or purchasing or buying or investing in the right tools to do your job properly. If you overcome all of those, if you flip all those around and you succeed, you overcome all of those, in that case, I think that you will, as we have on many projects, succeed in achieving a very airtight building. You should hopefully be able to build a building which is going to be comfortable, healthy, durable for the long haul. So I will leave it there. I have droned on for a long time. I was supposed to go on for 15 minutes. I apologize. I was hoping it would be faster than that, but it wasn't. So I'm sorry about that. I will close there.
You're being a Canadian. You're apologizing. You don't need to. We love you. We love your voice. We love your storytelling to the point where someone mentioned that there's the Passive House kids book. You should be the one that reads it to us all, maybe at Christmas, because we would all just sit back and just love that book that much more. So everyone hold on. I've got the question queue lined up. We're heading over to Zach for some stuff. Over to you, Zach.
Yeah, absolutely. So I just want to take a moment to thank the fine organizations that help make us make the programming that we do at the Passive House Accelerator possible. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minitaire All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Also, thank you to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. Thanks to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. And thank you to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan Insulation and Air Tightness, Brooklyn Solar Works, Euroline Windows, Enotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So thank you, sponsors.
Great stuff. Thanks, Zach. Thanks to all the sponsors that make this event carry on and the accelerator. It's great. So there's a long list already gathering here. And Ed, just take a second as I read out the list here. You can get a pat yourself on the back. There's lots of great kudos to you in the chat here. So we've got Sean, Jeffrey, Jason, Zoe, Patricia, Derek, Colin, Mick. Let's get into it. Sean, Rose, over to you.
I think you answered my question with some of the last items there. I asked if thermographic imaging was a standard operating procedure, and I got the impression that, yeah, it is.
It should be. It should be. As I said, 10 years ago, would have set you back a pretty penny to get yourself one of those cameras. Nowadays, they've come down so far in price. They're so useful. They're so easy to use that I couldn't recommend them enough. I really do think that everybody should have one of those, whether you're on the consultant side, the design side, the build side, the test side. It's such a useful piece of technology. Sometimes, if you're doing a blower door test in the middle of summer, it's 75F outside and it's 75F inside. Well, it's not going to help you very much. But if you're, in a cold climate, it's cold outside, it can be incredibly useful in those scenarios.
Yeah, I looked at one a few years ago and it scared me, and I hadn't looked at it since. So I appreciate that.
They make a nice little, the one we have is a small one, and it's kind of built for job sites. It's got like rubber bumpers all the way around it. It's got a nice touch screen on it. And I think it can't be more than $500 or something like that. Somebody maybe will check me on that, but I think a few years ago, at least, that's what it ran.
Great, thank you.
So just on that note, I'm going to bump ahead because Patricia kind of asked that question too, is what is a good priced infrared camera? So if you want to just clarify, the one that you had, or I know the one I'm looking for is the one I'm going to put on my smartphone, but do you? I
was trying to look for it. I had it on my desk here somewhere. It was
I think Sam borrowed it. I think Sam has it.
It's about yay big, kind of looks like your wallet or something. Looks like a phone, looks like a cell phone. It's about yay big. It's not the gun, the point and gun one. I don't, it's around somewhere. It's in our office somewhere here, but we have 2 or 3 of them. I can find the link. I think it was the one, ONE. I think that was the one.
Yeah. Susan put that in the chat. So you're good there.
Awesome. Thanks, Susan.
And I think more people are making sure they're getting, hopefully Fleur can give us a discount code for all of us, because I'm sure that's on my list to buy. So we'll work on that.
Fleur is good. I was just having this conversation with my partner, John, the other day. We had a contractor who was saying, oh, could we borrow your blower door test? Yeah, of course. That's fine. You can have our blower door for a week. We certainly have done that kind of thing. But also, I don't know, I maybe in my old age, I'm getting crotchety. Like, buy the tools to do your job properly. Like, it's only if it's, they're not that expensive, and you don't even need the one with the fancy computer on it. Buy yourself a powerful fan and a piece of plastic and test the air tightness. You can go around with your hand and you're going to be able to feel the air tightness. It's not rocket science. There's no magic to it. So yes, we do commonly loan out these types of things to folks if they're only doing 1 or 2. But my feeling is, get yourself the right tools for the job, for sure.
Yeah, no, I agree. Great stuff. All right, Jeff Rodin, over to you.
Ed, give my best to John. He was my
Hey, Jeff.
trainer. Along with the other thousands that you have all trained. But I'm wondering if you'd comment if is there any difference between sort of the multifamily world and the sort of single family townhouse kind of world when it comes to blower door issues?
Oh, that's a super good question. Yes, I think when it comes to multifamily, I guess what I would say on that front, and I'd be curious to hear from some of the folks who do a lot more multifamily than we do, I think you need to approach the blower door testing as a design problem. You actually have to design the building, and you have to be thoughtful. You have to think about that test as a design problem. You have to actually design the test. You have to build in ways to compartmentalize or segment off the building. You have to think about phasing and how you're going to complete the project, especially with big projects that are going to get completed. They're going to get certificates of occupancy in phases. You need to think about how that testing is going to get done and implemented. It's really a whole design problem unto itself. And you need to approach it that way. You need to actually plan it out. You need to work with all the folks who are going to be involved and schedule it out. At the small residential scale, you can kind of just roll up in a truck and dump the blower door test out and kick everybody out for an hour, do the test real quick. With the big buildings, it's a whole different ballgame. It really takes a lot more planning, and you really do have to be much more thoughtful about how you approach those. And oftentimes you're going to have to phase the tests. You're going to have to test this chunk and then that chunk. And then the other piece of the puzzle that has sort of bit us on a few projects is the occupancy. You might get to a situation where the building is partially occupied. And well, now what do you do? How are you going to test the building? You're going to ask everybody to keep their doors open for a few hours all day, every day. And then there's security concerns and access concerns. There's all sorts of issues when you're trying to test occupied buildings like that. So yeah, the big buildings are a whole different ballgame. Never mind the technical issues around pressure balancing, tall buildings, that kind of thing, just the sort of personal issues or the sort of human issues around organizing.
But the other challenge that I find that with blower door testing is that people think of the air barrier as a two-dimensional problem, not a three-dimensional problem, like a wall, right? You're demising walls, they're three-dimensional. So just, having the air barrier defined as the left side of the wall and then going to the right side of the wall, you got to have that little bit in there in between.
That's a really good point. And that's partly about how we draw these things too, right? Where you're drawing these things in two dimensions. It all seems tidy until you get to the corner, and then you go, how do I go in three directions like this?
Great stuff. Thanks, Jeff. We are over to Jason. Jason, want to pop on? Jason's question. Sorry, I don't have it right in front of me, everybody. Let me go up in the chat.
Sorry.
Oh, all good. Fire away.
If you do you have any experience with overhead doors, whether they be garages or auto shops? Because I've had to blower door test seven of them today, and it went about as well as you expected.
I have no experience on that front. That's amazing. That's super interesting. No, I can't say that I do. I do have an idea of how it went, but how did it go?
Well, it's a car dealership made of concrete, so they were basically the only holes in the entire building. So it's not passive house, but it was all right overall. And it would have helped if the weather stripping was not if there was no daylight peeking through the weather stripping either.
Yes. Yeah. That's the thing, right? You don't need this sophisticated technology. You just need eyeballs. And when you can see the sunlight coming in under the door, well, it's a pretty good bet that that's not airtight.
Okay, thanks, May.
Hey, Jason, just on that note too, you can check out, again, different doors. Again, of course, right now they come in from Europe, but the Passive House up at UNBC had a crazy door they brought in. And then the car dealership in Red Deer, Alberta had some pretty skookum garage doors for those facilities. So check out those buildings. So UNBC and Red Deer, Scott Subaru car dealership for that one. We're over to Zoe Kaufman. Zoe, I know you had a couple questions. Let's just hit one before we turn over to the after hour. Zoe? Zoe?
Yep, Zoe. I think I just had one question. I can't turn on my video, so you're just going to have to imagine. But thanks, Ed. You know me.
Absolutely.
So I was wondering, when you were saying that you kind of sometimes plan strip heating where your doors are that you expect to have infiltration, what do you enter into energy modeling? Like how much do you assume that the door is going to leak?
That's a good question. We have a process that we've worked out with PHI over a couple of projects to essentially try and estimate the contribution of that heating, the amount of heating energy that's going to come from that electric resistance heating or that electric strip heating around the doors. So what we do is we do something of a climate analysis, and we try and identify the sort of number of hours or degree hours per year that in that climate it's going to be below a certain threshold. You know, the thresholds that we're concerned about around thermal comfort, radiant temperature asymmetry, and draft discomfort, that kind of thing. And then we look at the mechanical systems and we say, well, as a percentage of the total wattage, installed wattage of heating in the space, you know, what is the heating element there? And then we can kind of use those two things to work out essentially like a percentage of the total annual heating, which is going to come from the strip heating elements there. And it's always in the neighborhood of like 1%, 1.5%, 2%, something like that. You know, it's a very small amount. And then we enter that in either PHPP or WFI as an additional load there around the heating. And really where it matters is when it comes to assessing the total source energy demand or the primary energy demand, you know, depending on which standard you're working in there. You know, that's where you'll see the impact, because obviously electric resistance, you know, not as efficient as your fancy heat pumps or, you know, whatever it is that you're using there. So yes, we have worked out a method there. It's a little bit weird. You know, certainly I could imagine some even more sophisticated methods using, you know, dynamic modeling to sort of assess it, but that has been successful. That's been good enough for our PHI reviewers so far to accept.
Got it. Thanks.
Sure.
Great stuff. We're over to you, Zach.
All righty, thank you. So I just have a couple of quick announcements, and then we'll get back to questions with Ed. So on the Passive House podcast, we've got a great interview with Juhi Lee Hartford and James Hartford. Juhi Lee and James both presented about their super cool Theus retrofit of an old historic laundry. It's now their office in Hudson Valley, and they are pioneering passive house practitioners in Hudson Valley. They've also done a cool new cidery. So anyway, the conversation talks about how they met, their motivation, the motivation behind their practice, and observations about their team of builders. And it's a great conversation with two very experienced and gifted practitioners. Next week, we continue the air tightness theme with none other than Kevin Brennan, who will be talking about smart air tightness strategies with some field examples, and it's going to be a great construction tech edition of Passive House Accelerator Live. So we hope to see you next Wednesday. That's Wednesday of next week for Kevin Brennan's presentation. Then the week after, we're joined by Sean Taylor, who is based in Australia, and she'll be talking about the Team Green Passive House. You may, if you listen to the Passive House podcast, you may recognize Sean as one of the guests that we've had on that program. And we're really looking forward to having a presentation from Down Under again on Passive House Accelerator Live, at this time for the Project Showcase Edition. And then on February 17th, so the day after Sean's presentation, we'll have a Passive House Component Spotlight with Proseco. This is our first Passive House Component Spotlight with Proseco, and they'll be talking about air barriers. So we're consistent with our air tightness theme, air barriers for passive house retrofits and new construction. And I have a registration link that I'll include in chat in just a moment. So that's it for me. Thanks.
So just closing out the hour, I just want to say thank you, Ed. Ed, this I've got to add to my gratefulness list. You definitely make it. This was the highlight of my day. It really good. Like I just you're a great, funny instructor, and pulling together thematically those three major categories, like so many little things I've heard over the years, just pulled together in a marvelous way. Thank you so much for joining us today.
I think we can all second that. So as we kick off the after hour, again, some of you may need to leave because you've got other obligations. Some of you might be on a Thursday morning and you're got to dive into work, wherever you are on this lovely planet. I know we had some people in from the UK tonight. Thank you. We've had some other newbies to the show tonight. Thank you for joining us. We hope you return, but you do have homework. You do need to bring a friend next week so that we can, again, get this thing ramped up and accelerate to a higher level. So thank you for joining us this week. We still have more questions. The list of questions for the after hour kicks off with Derek, Colin, Mick, Timothy, Ian S., Sebastian, and then Reed had a question at the end, and we'll see what happens in the rest of the chat here. Ed, fantastic stuff, but we're going to fire you some more questions, starting off with Derek. Derek, you still with us?
I am. Good morning. Ed, by the way, your mastery of neurolinguistics is amazing. I firmly agree with everybody who says that you should be doing the reading of anything, including the Passive House book, really. But actually, the presentation was so well experienced. You know, that's what I was impressed by, of course. But my question is around the operation of buildings. So, you know, the majority of costs in a building is not the construction, it's the operation afterwards, of course. And so, because products can fail over time, whether it's, you know, cracking, et cetera, what have you found and what can you recommend as far as, you know, a blower door test is certainly a rather traumatic event. It's a rather big event that goes on during construction, right? And so, you know, how do you avoid having to redo that? Are there any tools that you have found? Are there prescriptive methods? You know, what can you discuss in that topic?
It's a fascinating question. Well, thank you for the kind words. And before I answer, you know, thank you to everybody at the Accelerator. You guys do such an amazing job. And thanks again for the invitation to be here. You know, it's great to be with you all. And it's an amazing thing that you guys do here, organizing this week in, week out. It's really just incredible. So thanks again to everybody for being here. And thanks to the Accelerator for organizing this. That's a super interesting question, Derek. I think that the reality, I guess what I would say, and not being very much on the building operations side, you know, my experience here is rather limited. What I can say from my experience is that mostly what happens is that when there's a problem, when there's a visible problem, when there's a clear evidence of a failure, is when we go back into leak tracing or sort of mitigation mode. Things like condensation on windows, condensation on door sills, evidence of mold, heaven forbid. Those are the types of things that, you know, would cause a team to sort of revisit questions of, oh, is this actually working properly? And I think the most common of those is going to be around windows and doors. You know, the windows and doors are great, but they move around. Kids throw baseballs against them, hang off them. They get slammed when people are angry. You know, there's all sorts of things that happen to windows and doors that can cause them to get out of kilter over time. And I think that's where we're going to see most of the failures. And then luckily, or I don't know if luckily, but the evidence of failure is very clear in cold climates, because you'll start to see condensate formation on some of the frame elements there if you do have that kind of leakage occurring. And so commonly that's when people reach out to us, you know, again, not being on the operation side myself, that's when we hear about it, is when there's evidence of a failure or an issue over time like that. But I'd be super curious to hear from folks who are smarter on the operations side, because again, I don't have a ton of experience on the operations side myself.
This is one of those old timers questions. It's like, because you need people that have put in systems 10 years ago that are now, you know, still in contact with the homes or buildings, and then able to say, you know, it's like, oh, this is what we found.
Yeah.
You know, I mean, I make a product, so of course we have like the indoor air quality light switch sensor, but there's additional sensors, and one of the ones I was considering was an in-wall humidity sensor. And, part of the reason was to identify before it becomes a problem, those kinds of circumstances, right? In other words, just a little bit of, we joke about put a little active in your passive, but, the reality is there's always times in the overall life of a building where, do you want to just kind of wait, build up, and then have a big expense of redoing, a blower door test, or can you detect that at a low cost over time and then say, okay, you know what, we don't have to do it every 5 years, we can do it every 20 years, something like that.
Oh man, that's so smart. Yeah, that's a really good point. We used to do more of the sensoring, the sort of interstitial sensors, humidity, temperature sensors inside of wall assemblies back maybe 10 years ago when we were doing this. I will admit the last four years or so, I don't think we've installed any of those, but not on purpose. It's just sort of that's an important thing, but I don't know, we've sort of lost the thread on that a little bit. I think it's a super useful idea, especially if there's some way to automate the sort of evaluation and checking, send alerts or something like that. Yeah, that's super useful.
Yeah. See, your expertise may give you that leg up where you don't feel the need to do that. But think about all the new people that are going to start to do these techniques, and they're going to make the same or similar mistakes that you've made. So
Right.
they are kind of going to be starting in that problem. And now we're multiplying it times, 100, hopefully, or more. Not multiplying is a problem, but it is, yeah, we have to do as many things as we can. Like you said, get the right tools for the job. So anyways, hopefully I've stumped you enough to be desired to come back and present on that.
Someday I'll come back and do a monitoring. There you go. That's a great idea.
Yeah, thank you.
Absolutely.
Yeah, Derek, we're always good at getting Ed, at least once a year on the show, but I'm sure we could throw a topic at him and get him back on. So good job.
I'm going to come on one of these days, Sean. I'm going to come on and I'm going to show you guys all the software that we've been making for Woofy and for VHPP. We'll do that someday when you guys really want to nerd out. We'll show you that stuff.
Yeah, because you're on, you're, I guess, one of the few presenters we've had on multiple times, and you did talk about that the last time. So
that was the germ. That was the beginning.
Yeah. And I think we had to say that's actually, I don't think it's published because we talked about it in the after hour, the overtime, I think, of the construction tech way back in the early days of construction tech,
Right.
Almost a year and a couple months. Okay, moving on. Mark wanted us to cheers, and I didn't do a good enough job. So everyone raise a glass, whatever you're drinking. And to Mr. Ed May, you're brilliant beyond everything, and we were lucky to have you in our lives.
You're here.
You guys are too kind. Thank you so much.
Again, it takes a village, but we sure like you being in our village. Okay, next in the lineup, and I apologize, I haven't keeping track of who's here. We're still got 100 people, which is fantastic. Colin, you were next in the queue. Colin, are you still with us?
Yeah, I'm here.
You're next.
Hey, Ed.
Hey, Colin.
Hi. Actually, you did my passive house training in LA about 5 years ago.
Oh my God.
You
Yeah.
were you subbed in for Tomas.
Yep. I remember.
So
That was great fun.
yeah, that was awesome. So thanks again. So my question is about smoke machines, like either handheld, but I'm kind of more interested in, kind of the ones you'd see at a rave or something where you can, pressurize the building, fill a whole room, fills a whole level, and just kind of see it disappear. Is that something you guys typically use? Do you have that in your arsenal?
They're both awesome, but also a challenge. It's a great idea. Again, I was just talking with my partner John about this, and he was saying, how useful they can be. Sometimes when you're on a job site and there's leakage, especially when there's leakage and you're not achieving your goals, people go into defense mode, and it's like, no, it's the problem is with the windows. It's not my problem. It's a problems with the windows. Well, I don't think it's a problem with the windows. I think it's a problem with this. It's the windows. All right, well, let's do a smoke test. And then when you see the smoke billowing out from, the floor to wall junction, you go, well, it's not the windows, is it? They're incredibly useful. They're incredibly visceral. You can really see what's happening, and it all becomes very tangible to everybody on the team, sort of exactly what's happening. The challenge I perceive with them is that it can be much like a leak in the ceiling, leak in the roof. You see water come through your ceiling, Well, you know there's a leak in the roof somewhere, but it doesn't mean that the leak is directly above where the water stain in the ceiling is. The leak could be way over there, but then it runs down the joist and kind of comes out. And it's kind of the same issue. The smoke test can be useful for getting a rough idea of where the leakage is happening. Is it the windows? Is it the floor somewhere? Is it up at the roof? But it doesn't help you sort of really pinpoint exactly where it is, but it at least kind of narrows your zone of analysis. So I think they can be incredibly useful. I think they actually can be very, very useful. One of the reasons that we don't use them a ton is that because we work on a lot of retrofits of attached townhouse projects. And in those cases, when the neighbor starts seeing smoke coming out of the walls, that can be a challenge to explain what exactly is happening in that instance. So yeah, it can definitely be a challenge there. But I think it's a great tool. I think it's a super useful tool within bounds, within limits. We do have one of those like theater foggers, and we use it. We deploy it on lots of projects. It can be super, super useful.
Okay, yeah, it seems like it would be more useful on. I'm in British Columbia. We're testing for step code, so it's a lot leakier. And so if you can just, oh, there it is, it's going straight out the window, as opposed to, you know, if you had a double wall exterior, you know, multiple layers of air penetration, you wouldn't see exactly where it goes.
Yeah, I think I think the ability to see it is hugely useful. I didn't really talk about it much, but you know, those smoke tests, smoke pens, that kind of thing, incredibly useful. The ability to visually see, you know, that's so powerful for everybody on the team to be like, oh, there it is. One useful hint in case anybody is interested, you know, those smoke sticks are great. Some of them could be quite caustic, you know, the fumes and stuff that come out of them. One technique that, again, my partner John is sort of using these days, it's going to sound stupid, take an e-cigarette and you attach one of those little bulb things that you use to suck boogers out of babies' noses. You like attach it to the end and you can sort of puff it, and then the sort of e-cigarette smoke will come out, and it's, you know, strawberry flavored. So it's a much nicer thing than the sort of commercially available smoke sticks. And you can get turkey baster. Yeah, thanks.
So just to clarify, you guys have like a theatrical like fog machine?
Oh yeah.
Yeah.
Yes.
Yep. So it's not like a specific something you buy from specific to building testing.
No, we're in New York City, so it's a Broadway, like a theater. Awesome. It's a theater fogger. Yeah, it's one of the. Cool. It also has lights, so you can, if you want it to be like purple and red. We don't use that feature very often, but
yeah, only Fridays.
That's right. Yeah, exactly.
Yeah, Colin, go to the nearest party supply store and they'll have it, or you can rent them. That's typically where it is. I know out here in Victoria, he puts the red light on because it looks like he's like got this cool Ghostbuster machine when he's doing his protests. Cool. Aaron, I'm at Dynamic HVAC, and Aaron just gave me this tool, so hopefully you can see it.
Yeah, I've seen those, and I have a smaller one. It's not quite as fancy. They're great.
Where do you get this from?
I got it from Germany, but yeah.
Go to Germany, everybody, and get one.
Yeah. First, I got to go to New York, and then I got to go to Germany.
Yeah, that's what we're having.
Look Solutions is the US distributor.
Sorry, Lucy.
Oh, great.
Cool. Okay, thank you.
Thanks, Colin. Great question. Mick. Oh, now we're having a smoke party in our little space here. Behind me. Yeah.
Make it clear.
Mick, are you still with us? I gotta go figure out where your question is, but Mick.
Hi.
Great.
Wooly, yeah, is it mine? I can't remember. I think I made a comment while the chat was on, and it was very good talk, by the way, I would say. I really enjoyed it. One of the things I'm a first time, I've built one house, and one of the things that happened with me was I had a situation where I was in the position where my builder was didn't really understand about the need to make sure that the house, how to make the house airtight. And one of the things that I spent a lot of time sitting thinking about myself was all the penetrations that were going to go into the house. And the thing that happened for me was I very carefully put in a pipe from the inside to the outside of the house so that an electrician could wire through the pipe to an air source heat pump. And then when the electrician came to fit the wire, he was finding it was a bit tight through the pipe. And so, because I wasn't there, he just took the pipe out and stuck the wire in. And I got this flipping enormous.
Yep.
It wasn't great. Let's put it this way. Anyhow, I went ballistic, but we did manage to fix it all, and we got a very respectable result in the end.
Congratulations. Well, that's good news. That's good news.
Yeah.
But that's what it takes, right? Is somebody who's really paying attention and really focused on
Yeah,
it. Yeah,
that is the point. And I think it's very important to actually know exactly where every wire and bit of pipe work that's going in and out of a building is. It's obviously, as a self builder, just for my own house, it's not such a massive job as when you're doing a whole set of flats or something, but it's important just even on a single house.
Yeah, I agree. And the sort of thoughtful preparation that you're describing, you know, putting in conduit because you know that somebody's going to come along and have to run this, that, or the other, you know, that's the kind of thinking ahead and planning ahead that's so useful. You know, planning for services, planning for plumbing, planning for mechanical, planning for electrical, not just assuming, oh, I can design and build whatever, and those guys will figure it out, right? That's not the way it works with these types of projects. You really need to think about how are you going to route these things? How do you plan for them? How do you make their job easy by putting in the infrastructure that they need so that they can get where they need to get to. Yeah, that's a really a good way to do that. I commend you for that. Absolutely.
Thank you.
Well, again, thanks, Mick, for joining us because it's now, I guess, 1:00 a.m. in the UK. So
20 past 1. I think I'll drop off shortly. Yep.
Thanks for being with us.
I'll drop off to sleep.
Thank you for joining us again. And people join us, and they're in a passive house. So jealous of some
It's
of the.
great. It's a very nice house.
Well, again, maybe we'll, you got to message me. Maybe we can get you on the show. You can give us the experience, or maybe when you come to the pre-show, you can give us the details. You know, we and this is for everyone. We still want to get 3-minute videos of your passive house projects. We want to see these things. So don't forget about many months ago when I gave the presentation or Zach put together of just how do you create a 3-minute video. We do want those. Having the data and all these videos in a collection is just fantastic. So Mick, I know you're new, but I'm giving you more homework. You got to bring a friend next week, and you got to give us a 3-minute video of your place.
Yeah, we want to see this place. Absolutely, I'm excited.
And then when we're all able to travel again, we'll come see it in real life.
Yeah, I am sort of quite boring, and I'll take anybody around my house and bore them to death about the virtues of passive house.
Mick, we'll be the judge of boring. You're in a passive.
Cheers.
All right. Thanks, Mick. Moving along. So, Timothy, are you still with us? And Ian? And there's a few more. There's about 5 more people in the hopper here. So, Timothy, you still with us?
Ian's here, if I'll nip in. Just on the detail for the windows, it's come out twice, I think. Somebody else had put a wire heater on the base of a large window. I'm not sure if that was your project. Is that something that you have to fabricate every time on your own, or is there something that there's a product out there?
Oh, that's a great question. Yes, we use a couple different products that are available. If it's so for those really large lift and slide doors, what we've been recommending recently is a product by a company named Schluter. It's a funny SCH.
Right?
Yeah, they do. So especially if you're going to do tile, they make a really nice underlayment and an integrated heating element. Very low wattage. There's no magic to it. It's really quite a simple, straightforward tool. And that's a nice system if you're going to do a tile finish. So if you're doing tiling, I think that can work really, really well. If you're doing it underneath trim, or you're doing it underneath like a sill board or on the sort of sides of the window, which sometimes we have done as well on the sort of sides. In that case, we use a flat graphite element, which is made by a company, I want to say it's called Warm Step. WARM step or warm floor, one or the other, warm step, warm floor, something like that. But they're nothing we invented. It's nothing we put together. They're just products that we purchase and are able to deploy. Very low wattage, pretty easy to install. The one trick is that often the drivers for them are like this big. They're huge. I don't know why. I don't know what it is about them, but you need to sort of secret those drivers away somewhere. And so just plan for those things because they're pretty big. But otherwise, it's a super easy way to give the homeowner a button to push for like 6 hours a year when they are kind of annoyed because it's 12 degrees below outside and it's a slight a bit of a draft coming through those giant lift and slide doors. In my estimation, it's good enough. Those cases.
Yeah, it's a little bit more difficult to retrofit if you've got to hide that buck somewhere then.
Yes, it is. Absolutely. Good point.
Thank you, Ed.
Ian, we had Ian Robertson on the show many months ago, and it was the 6 or 7 flavors of timber. In that presentation, he highlighted that small piece of a radiant board that he had put in for those giant windows that they were so big that you actually measured them in Stevens because they're so giant. I think they're the
yeah, that's the one I remember. Yeah, it was huge.
We talk about the measuring windows in Stevens, and everyone's like, "Oh yeah, we remember that one." So yeah, check that one out. Maybe if Ian's still with us, he can find his own presentation. But he put that in, and again, I'm assuming Ian and Pierre Andre probably connected with Ed about that detail because they're a little worried about that comfort, and they added in last minute, and I think it's great what they did.
I think not to dwell on it, but I think there are a few edge cases. Bathrooms are another one. Washrooms, right? That's another one where historically in passive houses, we've seen people install a little bit of extra heating. Places where you don't have as much clothing on, where your skin is wet, where you've got a bunch of cold surfaces around you, hard surfaces. I think there are quite a few places where a little bit of extra heating can go a long way to improving thermal comfort of the occupants, even in a passive house. And especially when we're using things like, ductless heat pump systems that don't have super comprehensive distribution. I think that can make a big difference. And so we do recommend it in many cases.
Yeah, towel warmers, fantastic. You come out of the shower, towel's warm, and you've got the space because they're actually more costly, or they're more affordable than putting the heating under the tiles because the floors are typically warm anyhow. So you're still
Good
just
point.
a little bit of the 2 degrees, and who doesn't like a warm towel after a shower? So okay. Great chat and questions, everyone. Sebastian Monroe, if you're still with us, I'm sorry.
Yeah, I'm here.
Fire away. I think you had a couple questions or one, but it's
one main. Yeah. Hi, everyone. Thanks for the talk. I missed most of it, but just really good to be here for this question and answer session. I'm about to sit my passive house exam in the next 2 weeks, just done the training here in Australia. But we've got 2 passive house projects on the go. One is 2 townhouses with a basement that has a floor level below sea level, which, let's make my first project the most hardest one I can think of. We're using a system called Newton Drainage from the UK, Newton Waterproofing System. And we've found an engineer in the UK who has previously used it in a passive house. But the reason why I was asking about dynamic software to do the dynamic modeling is that I'm really concerned about condensation and mold growth in the basement because of the potential humidity. It's in a suburb in Melbourne that's right by the bay called Port Phillip Bay, and it's all in a really sandy, loamy type soil. So the water infiltration into the basement, even though we're using secant wall construction and this other system, is still going to be potentially high. So I'm just curious to know how to start working out the thermal bridge. I've done all start detailing the thermal bridging, but it's more working out the dynamic, cold to hot surfaces or hot to cold, depending on which season we're in here in Australia. And what sort of softwares or what sort of processes should I do to start doing something like that? Because I've read a lot of the books, but there's really nothing on things like that at all anyway.
Yeah. That is quite a challenging situation. It's a really interesting question. The dynamic energy modeling programs that we use, like Energy Plus, to assess energy performance, overheating risk, that kind of thing, are probably not going to be the right thing for that specific situation. It sounds like what you really want is a more discrete envelope modeling simulation tool. And so probably the first one that I would suggest you take a look at is actually PHI's condensation risk tool. So PHI, as part of some of their research work in Central Europe, has a really nice condensation risk tool. It's essentially a modified Glazier method analysis with some extra bells and whistles, some sort of like extra bits that they've added to it to make it more sort of featureful and useful. But it's relatively straightforward. But that one is that's not what we would consider a dynamic method. That's more of a static analysis method, but it'll give you a reasonable first stab at assessing condensation risk, mold growth risk, moisture risk. Now, again, PHI has kind of added some bells and whistles so you can actually see like annual performance. The Glazier method is historically a point in time assessment method, but they do a thing where they try and spread it out over the entire year. So that's a good first step. Then I would say there's another tool made by Lawrence Berkeley National Lab, which is the new version of Therm, THERM. The new version of Therm, and I don't know that it's publicly available yet, but there is a version of Therm that can do heat and moisture transport modeling at this point. So maybe check that out because that would be free. And then, of course, you get into the Woofy Pro. So not Woofy Passive, but Woofy Pro. But that's a much more sophisticated, much more complex modeling tool that requires quite a bit of sort of know-how before you really dive into it, because you can kind of get some weird results if you just go in and start pressing buttons. So it really requires somebody with a lot of experience to kind of show you how it works before. It's a really hard thing to kind of dive into if you don't have somebody looking over your shoulder telling you where the like secret edge cases are and the secret failure buttons are.
We've got a consultant who's a Woofy Pro expert. He's actually my teacher for the course. So
So get that person to do it. Yeah, there you go. Yeah, definitely rope them into it. But I would also recommend that PHI condensation risk tool. That's a good first order analysis method that almost anybody who uses the PHPP would be able to execute. In addition, I would say that the method follows very closely on the ASHRAE method. So if you want to see the background of like exactly how they're doing it, you can look in like ASHRAE Handbook of Fundamentals, like chapter 25. That'll give you like a step-by-step breakdown of exactly how to do that type of assessment. So you can kind of like see the example and see what it all means. And, you'll get a bunch of weird curves and answers and stuff, but you can kind of use those reference materials to see what the heck it all means, what the numbers mean.
Great. Thank you so much for the answer. Yeah, it's going to be an interesting result. It's a CLT 2 townhouse project with this massive underground basement. So I've been working on it for quite a while. And it's going to be designed for manufacture and assembly. So we're bringing all these different parts. We're going to be using the BIM to PH or BIM to PH tool. It's LOD 500. The client is the builder, and he and I had just completed the Passive House course together. So he and I do a lot of development projects, and the next project is potentially going to be a Passive House project. So we do townhouse developments, but it's just like he's going, oh, he's so excited now. And it's like, oh, I want to do this on my own home. And I'm like, yeah, let's do that. And I'm like, how do I do this basement?
Oh my gosh.
Well, good luck.
Thanks, guys.
I'm sorry. So for everyone that's still here, Ed, we're going to let you go, and Sebastian's now going to take over the show for the next 2 hours, and we're just going to carry on doing, because that sounds amazing as well. So Sebastian, please email Zach or myself, because we want to know more about this, because this sounds awesome and challenging, and we want to give you some praise for all of your hard work. And again, thanks for taking the courses and gathering a very effective and collaborative team. But we want to know more. So sorry, we signed you up to carry on. So again, first and third weeks of the month, project showcase. Second and fourth are construction tech. So, we can bring on, whatever you want to talk, but that's kind of how the Passive House Accelerator Live works. So you let us know, and we'd love to, again, go across the pond and hear all about it. So connect with us. So great stuff. All in all, sorry, everyone kidding. We still got 4 more questions here for Ed. So Ed, hopefully we can keep you going for a few more minutes before you part ways and we all have to carry on. Reed was wondering who is presenting, but he hit the link and knows who's going to be presenting for the ProCirco event. So he's good there. Barbara from Oz. So we're going to go across the pond again. Barbara, are you still there?
I am still here, actually.
Yeah, fire away with your question.
Okay, so I would love to build, I want to prefabricate, oh, sorry, my camera's down at the bottom of the computer. It's terrible. I'm designing my own passive house in Canberra. I want it prefab. I want a green roof, but I also want the photovoltaics put on top of the roof. Now, there are German companies, of course, because green roofs have been the law for like 30 years. Wolfgang Feist's building in Darmstadt has a green roof and it's wooden. So it's possible to do a green roof on top of a wooden roof, but can we also put the photovoltaics on? There's a company called Obergrün in Germany that markets photovoltaics that you put under the waterproof layer. But I want to know, is there a reliable electronic water monitoring system that I can put in the roof? So if it does spring a leak, I can tell where it is. And I don't have to rip up the whole roof. Any ideas?
Well, wow, that's a incredibly specific question, Barbara.
Yeah, so, and I'm sorry, because
No, it's
we're
great,
not
it's
going to
great.
be able to, we can't answer it with a smoke machine because this is assuming there isn't a leak to start with.
Yeah, absolutely. I have no idea. That's a very specific use case, and I have never encountered that, so I don't.
I'm sorry.
No. It's a super interesting one though. So what I would say is, I think there are absolutely several different monitoring packages that you can buy for water systems now. So there are many of those, and they can send you alerts if there are leaks, if they're able to identify leaks. So I would definitely take a look at those. When it comes to actually monitoring the interstitial cavity itself, the sort of moisture levels inside of the roof itself, there are definitely some useful sensors that we've used in the past to do that type of monitoring. I think the challenge though, those sensors are $30, $35 each. And it's not like you want to put one every, 5 every square meter or something of the building, right? You're going to kind of maybe put one. And I don't think that's going to give you very useful coverage, to sort of identify where those different areas are. So unfortunately, I don't have a great way to recommend for sort of comprehensive whole roof monitoring. There are sensoring systems that can be useful for embedding in the construction, but they're only going to measure at that point. So it's not going to help you with a sort of whole field assessment there, unfortunately.
Okay.
So I don't know if anybody else has a better idea though, maybe other folks who've run into similar situations.
See Derek wanting to jump in here. So Derek, I'll give you a minute before we carry on questions, but.
Yeah, I'm just going to say that the sensing, I've been doing sensing since '88. The challenge with the water detection, especially in that particular use case, is difficult because the ambient humidity can affect it. So for example, sometimes you can infer a leak through humidity. You have to kind of the rate of change. There are linear sensors, so it looks like a little rope, and you can string that along. Like you said, with leaks, it's not where you see the leak; it's someplace else where
it starts.
Yeah, by far. So we've all probably experienced that personally in our homes, right? So yeah, the challenge is you can do the same kind of techniques that you would do in bathroom leak detection, by the way, which is, you kind of seal up around areas and then you put the sensor in what should be the lowest point, where the water is going to tend to flow. So that's probably going to be your best bet in that particular circumstance. But there's keep abreast of what I'm doing, actually, because you can see some things like that that have to do with those kind of interstitial sensors. We were looking at wall first because they're near the light switches, and so that tends to be where a lot of the error occurs and the ceiling problems are.
Great. Thanks a lot.
Sure. Hey, Sean, can I offer a super brief anecdote around the sensors? I was once a judge for the United States Solar Decathlon. I'm not sure if anybody's familiar with that program. It's a house building competition for students, graduate students, to design and build solar powered net zero homes. So I was an engineering judge in the 2015 contest, 2018 contest, one of the contests out in Denver. It was great. It was an amazing experience. And one of the student teams had built a concrete building, and they were using a hydronic cooling system to chill the surfaces in order to cool the building. And I said to the students, I said, well, aren't you concerned about condensate formation? You know, you're going to chill this concrete building. Aren't you worried that you're going to have condensate formation? And they said, no, it's fine. We've embedded 65 temperature sensors into the roof of this 1,000 square foot, 100 square meter building in order to monitor temperature and humidity continuously across the entire surface of the building. Oh, I guess that'll do it. I suppose that's all you need. You just install one sensor every foot or so, and there you go. Yes, you can absolutely tune your building like that, for sure.
Excellent.
Amazing. Don't get me wrong. The Solar Decathlon's amazing. They were a great team. Wonderful. It was just it made me chuckle when he said, yeah, we have a sensor every square foot in our building.
I'm sorry, I burst out laughing there. They muted me, fortunately, but I was sitting like, that's where I know you from. Because there was a team, Orange County, that used LumenCache back in, it was that year, and I remember the results and things. But it's funny, yeah, you can definitely go overboard and still not catch it.
Maybe just one perspective on that. Perhaps the infrared flare camera can detect if the insulation gets wet in the roof. Then you know that you have a leak in that area. I think Kevin Brennan showed 2 weeks ago when I was showing the cellulose tricks and his experiences, that he has actually detected that there was a leak in the roof in one of his projects, because infrared camera showed a blue spot among like a pink field of roof insulation. So that could be a way to detect, maybe.
Very good. I guess David's next. I'm just stepping in.
All right. Well, thank you very much. Ed, great talk. Thank you for sharing your experience. I have a question. So I was recently called about a building that was having a condensation problem. And the building has been occupied for 3 years. And once the weather got cold, this year, it started to get condensation on the windows, and and actually even experienced a little bit of mold growth. And so, we were kind of racking our brains about what it could be. Thought, well, okay, maybe it was a bad batch of windows. It seemed a little unusual, as it's the house has been occupied for 3 years, and the humidity's been totally fine for 3 years, and it's past the drying out period of all the construction materials. We would have expected this sooner. And so one of the things that we did find, and we thought that we had the problem solved, is that the intake for the ERV had actually gotten clogged with yard debris and stuff. And so we had the homeowners clear that out, and that actually seemed to clear up the problem for a few days at least. I'm not sure how long. And then the humidity started to creep back up again. And so right now they're kind of managing it with dehumidifiers. But and so the next step, what we told them to do, and it hasn't been done yet, is to hire a duct cleaning service. Maybe some additional debris had actually gotten through the screen and into the duct, or there's some other clog. But anyway, I just wanted to put it out there and see if you had ever dealt with anything like this, and if you had any ideas of where else we might look for further troubleshooting, because it's frankly has us a little bit stumped. We know the house, I would call it a passive-ish house. So it didn't, it does have, basically continuous insulation. It has very good air sealing, not totally passive house quality. But I think, trying to remember what the air tightness was. Not quite passive house, but far better than code. It has an ERV. It's a good house in general.
Yeah, that's a really interesting question, and thanks for sharing. It's an important thing. It's an important topic, and it's absolutely something that we run into. We run into it both on certified passive houses on both ends. So we had a client call the other day, and they said, we just returned from 3 months away in Florida, and our house is a little dry. Well, yeah, there's nobody living in your house for 3 months. It'll be a little dry in the middle of the winter. And then we have other clients who say, it's too humid in the house and we're having condensate formation problems. But I would also say that we have heard from many folks who build the passive house-ish projects that those are actually the cases where we see a lot of these kind of issues cropping up because. And I agree. We haven't quite sussed out exactly what the problem is. And for the most part, these aren't our projects. So we're sort of on the outside looking in. So I hesitate to make too many claims about them. But one of the things that we've seen, there's a couple of things happening. One of the things that we've seen is that if you start to build a really airtight building, you build a nice airtight building, one of the things that it does is it keeps humidity in the building in the wintertime. That's a good thing. It's going to help raise those relative humidity levels. If you have people in the building breathing and you have plants and you have cooking and you have all the normal things going on, it's a good thing because that's going to help everybody stay more comfortable. It's good for your mucous membrane. It's good for your health. It's good for everything. It can be a real challenge, though, to have high relative humidity levels in a building that doesn't have passive house quality envelope components. So if you use even kind of modest passive house-ish windows, but not really passive house windows, and then you have 45% relative humidity in the wintertime, well, those windows are really not designed to operate in that type of humidity environment, right? They're used to seeing 20% relative humidity in the winter, and then they're fine. But when it's 45%, well, now you run into some issues. The other thing that's happening is that in passive house-ish projects, the installation of those windows is often, I don't want to say low quality, and I certainly don't mean to say that you guys did anything wrong with your project. I'm saying these are what we've seen in other projects. We've seen people mount the windows on the outer surface of really thick, well-insulated walls. And so now you have the window way out there, really far away from any interior heated air mass or any interior heat source. So you've got the window way far away, and maybe you chose to compromise a bit on the window spec. Again, I'm not saying you, I'm saying, some of these other projects that we've seen. And that coupled with problems with the ventilation can lead to really high relative humidity and then condensate formation. And the problem that we have been seeing on the ventilation side is kind of a different problem, but kind of similar. There's a segment of builders, and certainly, colleagues of ours are in that boat who, they've educated themselves on a lot of this stuff. They know that using a dedicated ventilation is important, and somebody told them they were supposed to buy an ERV, so they bought an ERV, but they didn't really understand the nuance of it all, and so they just have the ERV dump an air into the basement because somebody, the brother-in-law said it was fine, just dump all the air into the basement and that'll be sufficient. So you bought an ERV, but then you didn't actually install it properly, balance it properly, do the distribution properly. And so you're getting high relative humidity over there and low relative humidity over there, and you're not getting the proper balance throughout the entire building. And so some of the problems, like the ones you're describing, we definitely see come up in our fully certified passive houses, 100%. But more often we see them pop up in these kind of near-ish passive house buildings where it's like, well, I built a really thick wall and then I have a small heating system and I kind of have weird air tightness, but not very good ventilation. And so that combination can come together to yield real challenges, especially around those window products.
But when do you see them pop up as problems? I mean, do you see them 3 years after, or do you see them pretty soon? You know what I mean?
Yeah,
that's part of the thing that's stumping me about this.
Yeah.
The house has worked for 3 years. It's been occupied for 3 years. It's been fine.
Yeah. Well, it depends a little bit on climate too, though, right? Sometimes if you have too warm, mild winters in a row, and then only the third winter do you get those really low temperatures, right? Because it's just a combination of temperature and relative humidity, right? If it's cold enough outside and the relative humidity is high enough, that's when that combination occurs. And sometimes we get really, I mean, around here anyway, we can have very variable winters. Sometimes we get super mild winters. We never get a flake of snow. Today, there's 6 inches of snow outside, right? It really does vary quite a bit. And so you're absolutely right. Usually you would expect to see those things pop up right away. But if you have a couple mild seasons, maybe you wouldn't see it until the end. Again, I don't know that that's the case for what you're talking about. I think you've got your finger on it. It's probably a ventilation issue. That's my guess, is it's probably a ventilation issue.
Yeah. I think there's something probably clogging the duct. And it got better after the intake grate was cleaned, but then maybe the increased suction kind of dislodged something else, and I don't know. We haven't gotten in there yet, but
the ventilation is a huge challenge. There's no doubt about it. It's definitely been the biggest challenge on a lot of these projects is not only properly designing, but getting it actually configured properly and then working properly over time. It's a huge challenge. I agree.
Yeah, cool. Well, thank you very much. Appreciate it.
David, again, great to see you. Sorry I had to sneak out.
Great. It's good to see you too, Sean.
Nice to have you.
And congrats, man. I heard you got a new gig.
Yeah, we'll talk about it as we wrap up. Thanks, David.
All right.
We've got Shannon. You still with us, Shannon? Are you having your dinner or?
No, I'm here.
All right, fire away.
Thanks, Sean. Great presentation, Ed. And really like that little troubleshooting conversation. And before I ask my question, I just want to say, have you ever been in situations where you felt like you had to go back and like recommission or retest after occupancy because of things like that?
That's a great question.
Rebalance the ducts.
Yes.
Are the airflows still doing what they were doing before? Did the homeowner change the settings somehow, or some of the vents have adjustable airflows if you turn them, and
yes, that's such a good question. Yes, absolutely. Especially 10 years ago, before we knew how to use the energy modeling tools. And we were doing things like specifying high gain glass in New York State, which is not a good idea. And we were having overheating issues on that first generation of passive house projects. We absolutely had overheating issues. And there were several projects where we got called in by the homeowners and essentially told off because the project was not performing the way that we had told them that it was going to perform. And that was 100% our fault because we didn't understand how to use those modeling tools properly. Right. And we were making mistakes. We were just screwing it up, and we were specifying the wrong products for the wrong climate. And we were meeting the passive house goals, but we didn't understand the nuance, and we didn't have enough experience to know that we were screwing it up. And so, yes, absolutely, especially earlier on it was more on the overheating side. That's really where that first generation suffered, and where we were hearing about it from people was on the overheating side and the summertime comfort side. It was very rare that we have people call us up and complain about the heating. That almost never happens. Sometimes we hear about, oh, it's too dry, or oh, it's too humid, but usually those are pretty short-lived issues. For the more common were those overheating issues. As a result, we've become incredibly conservative when it comes to glazing specification and shading. Some might call us overly conservative, but we're a little gun shy now after that first generation of projects there.
Yeah, and that comment about the windows and where you put them in the envelope, and then just knowing how things are adhering properly to substrates, even if you're staying within the same family of products. But the question that I had was about penetration schedules, and if you use them, if you recommend them, and if you do, how do you organize them? Do you do it by trade, by location, by material? What's your advice there?
I don't even think I know what a penetration schedule is.
That's like a window schedule.
It's way beyond my pay grade. I don't know that one. That's new to me. That sounds cool.
So I have yet to make a good one myself, and that's why I thought maybe, and maybe there's someone else on the call that has done it and has advice.
So would this be like, you're saying like
a window
listing
schedule?
out all of the
list out all the holes so that the contractor has to go through and check every hole.
What a good idea.
And then also, it's for us to say, oh, did I get all the electricians, or did I get all the plumbers, or did I get all the HVAC, yeah.
That's a really good idea. You know what and I'm curious to know everybody's thoughts on this. We've struggled with this in the past. We've tried several times to make kind of general checklists, but they're never really well calibrated to the specific building. And so then we kind of start ignoring like 30% of it. And then like after 6 months go by, you're ignoring like 60% of it. And then pretty quickly they like never get taken out of the drawer again. Like I feel like we've had a lot of challenges making useful inspection checklists and sort of like keep them in our mind checklists. And I don't think we've ever really come up with a successful method for that. Maybe that's just us, but yeah, I'd be really curious to know your thoughts on how to do that effectively for sure.
Well, maybe we should just start to crowdsource this one.
Yeah. Well, so just to go back, Prudence spoke about it in her presentation. Geez, I forget these dates now, but she kind of mentioned it, and she was creating it when she was with Morrison Hirschfield. But I saw our good old friend Melvin here talk about it. Melvin, do you want to chime in? Or I know last week your voice wasn't so good, so let me know if you wanted to.
My voice is much better now.
Great. Nah, good.
Yeah, I've only heard a presentation about it from Hilti. It's more for fire stopping. So you can ask them to do it. I haven't seen it in our own project, but I've heard them present about it. And they do a full penetration drawing and number it all and list it to the appropriate UL or ULC listing. But not for air tightness, but I don't know why you couldn't use the same theory and apply both fire stopping and air tightness for penetrations.
There is one thing that we do in our air tightness training for trades, and I don't know if it's as fancy as it deserves the word schedule, but we break our air tightness training into pieces by trade, so electrician, mechanical, and we take the drawings, plans, and elevations, and we highlight all the penetrations through it that affect that trade, and then we put it into a tabular form that shows, here's all of the ones that you need to worry about. And if there's a reference to it on a drawing, we kind of cross-reference that. So we can print the presentation out at the end and then give it to the trade, and then they have that kind of in their toolbox. It does take labor, time, like our labor and time, but we do find that it gets people other than the general contractor thinking about penetrations.
Oh, that's cool, Gary. And when you do that, do you do that in like a training session in the beginning of the project?
We do, yeah. Yeah, that's we kind of do a global training session, which kind of attracts, I don't know what I call them, the office staff. And then we usually have to do a detailed training session, trade by trade, a little bit deeper into the project. And again, we're not doing houses, we're doing multifamily and that sort of thing. But again, we found it's effective so that the plumber knows, I need a gasket, I need to slip that gasket on this pipe now, and then the contractor can come later and tape it to the air barrier. So they kind of all have that in mind.
Great idea. That's fantastic.
Great stuff. And if everyone doesn't know, Greg, he was on last week's with Construction Tech. Geez, I can't remember what happened last week there, Greg, but check out all the great stuff he's doing in Hamilton with the team there with Invidge and Indwell. So great stuff, Greg. Thanks for popping in there.
I also use, if you're doing your documentation in BIM and you're compliant with IFC4, there is the category, for voids in the IFC schedule that you can then categorize a window opening as a void and then schedule it out separately. And if you're doing your ID numbers correctly for all your elements in your building, then you should be able to schedule out both the numbers separately with the IFC category, and that will create a size and dimensions for every opening in your building.
So
that's deep.
Why stick around in the after hour to get snippets like this. Like, again, I said skookum. That is a scoopum tip of the day there, Sebastian. So hopefully others know what he was talking about and can do that. I think that's fantastic. Sorry, Shannon, I cut you off there.
Oh, no, I just said that's deep. And all I could do is think of Steve Hessler.
Yeah. That's one we got to share with him. All right, everybody. Well, we got 10 minutes to the end here. And so I think we've got everyone's questions. Hopefully everyone's happy. Great turnout. Again, love seeing people from all different parts of our lovely world. Great to see we got even, went up to Alaska with Mark Houston there. So thanks, Mark, for chiming in. And again, all of our friends across the pond that are into Thursday. We're still into Wednesday evening. So on the note too, you talking about penetration schedules. I've now changed jobs. So I'm now going back into the construction market. I was jealous of all you builders doing all these great air tightness scores, and I wanted to get in there as well. So I'm actually in the process of creating a penetration schedule as well. And that from a builder, I'm literally just looking at plans and marking it down and being like, that floor, that, you know, that light switch that needs to get taken care of. So I hear you all. So we're into those kind of details. For the multifamily, again, in BIMS has been fantastic. Single family homes where we only have 12, it's kind of simple, but we still seem to know how to screw it up. So connect with all the trades and make sure they don't hurt the air barrier. Well, everyone, let's give the other still here. Let's give Mr. Ed May one last cheers. We appreciate you so much, and can't thank you enough for coming on. Great.
Thanks for having me, as always.